All right, so for the directions on page 3, now we're going to be factoring um, a little more complex polynomial, but we have to remember from packet 1, when we were multiplying a binomial times a binomial, remember we used FOIL, but all of these examples are special cases. These are what we call our special cases, because they're really just a difference of squares. And I know that because this says x plus 4 times x minus 4. So when I go to FOIL this, I'm going to go x times x, which is x squared. Now I'm going to, and remember it's FOIL, first, outer, inner, last. Now I'm going to multiply the two outer terms. So that's a -4 and an x, so -4x. The inner terms is a +4 times x. So this is why it's special. Oops, I'm sorry. That's a +4x, excuse me. This is why it's special, because if it's starting out like this, then these two middle terms are going to cancel. And then finally that +4 and that -4, you're basically squaring the 4, but since it's a positive times a negative, it's going to always be minus and then whatever 4 squared is, which is 16. This looks really messy, but these two terms cancel out. So what you're left with is simply x squared minus 16. This would be simplified. So if you see a problem like this and they ask you to factor it, I'm going to go down to number 1 real quick. If they ask you to factor a squared minus 4, well, a squared is a perfect square because that exponent is a 2. And 4 is a perfect square. So I can square root it. And then this has to be a negative sign in order to be able to use this process. So when I go to factor a squared minus 4, I'm going to set it up with my 2 sets of parentheses. And I'm going to, what's the square root of a squared? It's a. So I'm going to put an a in both of those positions. And then one of them has to be a plus, one of them has to be a minus. And now what is the square root of 4? Well, that's a 2. So this is simplified form, this is factored form. Let's go back up to the review. If I were to, this is a difference of squares. So it's 5x plus 1 times 5x minus 1. You're basically multiplying the exact same numbers together, except one of them has a plus sign and one of them has a minus sign. So 5x times 5x is 25x squared. Outer, a -1 times 5x is -5x. The inner, 1 times 5 is a +5x. So these cancel. Finally, the last, a +1 times a -1 is -1. So when you go to write this as simplified, it's going to be 25x squared minus 1. That's a perfect square minus another perfect square. That's why it's called a difference of squares. There's your difference. This one. So I can technically skip this middle step because I know that O and I are going to cancel. So all I really need to do is say, okay, 2a times 2a, that's 4a squared. And then here, I have to put a minus sign right there. A 3b times a -3b, well, that's my negative, 9b squared. This is why they're called special cases, because they have certain properties to them. So 4a squared minus 9b squared, it's a perfect square minus a perfect square. Not only are the exponents perfect squares, but so are the coefficients. So here's the rule you're going to use. If you see a perfect square minus a perfect square, you're going to start by setting it up. You're going to have a plus sign in one, a minus in the other. You're going to square root the a squared and get a. You're going to square root the b squared and get a b. So if you factored a squared minus b squared, then it factors into a plus b times a minus b. Number 3. 81's a perfect square. X squared is a perfect square. I have my minus sign, so I simply set it up. I know I'm going to need a plus sign. I know I'm going to need a minus sign. What's the square root of 81? 9. What's the square root of x squared? X. And then that would be factored. If I were to refoil this, I'd end up back with 81 minus x squared. This next one, perfect square. Oh, perfect square, but that's a plus sign. So this does not apply for this. It would have to say k squared minus 25 in order to use this process. So since it doesn't, we say this is prime. You cannot factor k squared plus 25. Number 7, this is a perfect square minus a perfect square. So I'm going to set it up. I'm going to put a plus sign. I'm going to put a minus sign. The square root of 9b squared is 3b. The square root of 100 is 10. And then that's factored. Here, perfect square, perfect square. Set it up. Plus sign, minus sign. Square root of 16 is 4. Square root of a squared is a. So it's 4a. And you write that down twice. Square root of 121 is 11. So there's my positive 11. Here's my negative 11. Number 11, perfect square minus perfect square. So I'll set it up. I'll put a plus sign and a minus sign. Square root of 4h squared is 2h. Square root of 25g squared is 5g. This one looks a little weird, but it's a perfect square minus a perfect square. 1 is a perfect square. So I will set it up. Here's my plus sign, here's my minus sign. And the square root of x squared y squared is simply xy. And then the square root of 1 is 1. And then that would be factored. This is basically, I'm going to go back up here. This is reverse foiling. That's what this is, reverse foiling. All right, that's the end of page 3.